Hey, good morning. Good morning, guys. JFix, Silvio, good morning. Alessandro, good morning. Normington, good morning. Electro Rep, PC Settings, Thomas, good morning, guys. Another day, another boards to be repaired and laptops. Marius Natsa, Norbert Natsa, James, good morning. Hot coffee, yeah. So let's see what we have here. This must be Dell. I think we had one yesterday. Yeah, let's plug a charger. Yeah, if I remember, it was one with liquid damage, and I said I will not fix it. Ahmad, good morning. Joseph, good morning. How many repairs in this lot? I think we have like 6, 7, and we're finished. So plugging the charger in is doing nothing. Interesting. No, nothing. The meter is not coming on. Easy Pizza. Nah, you know what? I took my mind out from Easy Pizza. It's nothing Easy Pizza here. There are job lots and job lots, and I seen job lots actually, faulty laptops, but no one even open to fix them. On that kind of job lot, you have like 80% probably will fix from the laptops. But on the job lots, when someone checked already, they try to fix them, then yeah. You revise some of yesterday boards? Not sure what do you mean, Silvio. Thomas, good morning. I mean, what we is checked is checked. We are not going back to that. We are just moving forward. I never have had a easy fix on my store. The general rule, yeah, is never take a job which has been checked before or has been open. Because I have a bunch, I can't show you. I have a bunch of emails, like a lot. Oh, I opened the laptop and I swapped the SSD. I didn't disconnect the battery. The problem is nothing can happen if you swap the SSD with battery plugged in. But the problem is what the customer is doing. He has the laptop is working. He's closing the lid and he's opening the laptop. I mean, it looks like in these days, even my kids, no one is shutting down the computers. They just closing the lid. No, Silvio, no, the lemon masa. No. Am încercat ieri, am pierdut vremea, nu mai pierdem vremea iară cu ele. This board also has a barrel plug. Really? Yeah, here. Yeah, but how this can be helpful? Ciprian, mulțumesc. How this can be helpful? Because we have to fix it. The coffee is so good. I mean, this board looks like brand new. It even has a foil over it. You can see. I think the problem is a problem of the BIOS. You know what? You will be laughing. But you are same like one of my colleagues I worked before. So whatever happened, like no power, no picture, no whatever, it was always a BIOS issue. Nah, must be a bias. Nah, must be a bias. Like, he was not even checking the problem. Nah, must be a bias. You can't blame the things on a bias. Sorry, do you remember any poem in Romanian? No, I was performing poor in school. No. Reparați iPhone, so. Frankenstein time? Son, you must be British, but I can't do it. I can't. I tasted, but tea with coffee, it's something else. You don't like Dell? I don't like Dell because Dell is coming close to Apple. They are complicated things unnecessary. I mean, I'm not saying it's bad, but even now you cannot program this kind of easy chip. And you know what's the thing? The easy chip, which is basically, it's a controller, right? It's doing some like basic stuff. But just because you want to have gestures and BIOS and like a complex BIOS things, which actually is a simple thing, yeah. They start using an easy chip more complicated and more complicated. Wait using Dell 2 BIOS, Sergio. If you find a Dell with 2 BIOS, you're a lucky one. But if you check like XPS has like 5, 6 BIOS chips, memory chips, let's say memory chips. But most of the computers with the USB-C, all the computers with USB-C, they have at least 2. In this case, you have one here. You have another one here. And you have more. You have one more here. So here are 3. 1, 2, 3. Then that's all. Yeah, probably this is the old one. Andrei, salut. Okay, let me check the other board to see if we have spares. Okay, not sure if we have spares. Bore mode? No, 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 no. Let's stay away from bore view. Let's try to fix it, yeah? So plug in the charger and nothing happened. Let's check the main power rail. Main power rail, probably is here. And it's not shorted. Main power rail, probably is here. And it's not shorted. Good. Main power rail. And it's not shorted. So the main power rail is not shorted. Now what we can do is to find the PD controller, because there is something wrong with the PD controller. Or even better, but we don't have the battery. No. I'm gonna come with the power supply with 19 volts here at the input. We don't have, haha, look, dodgy Dell. So here is supposed to be a protection against, you know, high voltage on the charger ID pin. It's missing. You can see it. It's missing. Yeah. Let's come with plus there. Let's see what is happening. 19 volts. We have an inductor here and it's taking nothing. No power at all. Okay, main power rail. What is this? Is it a diode? Probably it's a diode, right? What is this? Anyone knows? What this board doing? Nothing. Dead. Diode. Okay. Okay, diode. The board is nice. Check here. Every power supply has a, you know, a test point. Wait, what? No, the capacitor got charged. No, it's taking no current. Has like, you know, you can disconnect any power supply. PD controller. TPS. Huh? We have a TPS chip here. Okay, let's check a few things. TVS, Schottky diode. Let's check a few basic stuff. Good, good, good. So it's not short here. Do you think actually is the charging port? No, probably not. No, the charging port looks perfect. No, it's not a charging port problem. No, perfect. I mean, I can't see anything else to do apart from, you know, replacing the PD controller. But we really need a board for spares. Yes, yeah, the port is good. The port is good. Microsoft, no, it's not the Microsoft, it's the European Union. They adopt USB-C as being a standard. We have 5 volts? No, it's not. The charger is not even getting enabled. But why no current from the DC in? Because if you have a dead PD controller, the AC should be speaking with the PD controller, the board need to not work. We really have to find the Dell from yesterday, which I remember had the same board. You remember from the last board we checked, the last one. Okay, it is different. But where is the PD controller? Wait, 1 second. Where is the PD controller on this one? No, these are the Thunderbolt chips. Oh, it's this one. You can't see this one. Okay. Okay, I found it. Yeah, it's that little prick, TPS 65994. Okay, this board is not helpful. So the question is what we are doing. Can we check the TPS? Yeah. 1 second. It is working. No, my meter is working with this on one side. So we have 19 volts and no current. Okay. So the cable has to be plugged like that in order to work. Okay, let's press the power button. So pressing the power button, which is here, and the board is not coming on. No, it's dead. Okay, let's check the main power now. No, it's not the cable, it's my meter. Main power L, 0 volts. What do you think about that? Why you have no voltage on the main power L? 1 second, here we have some MOSFETs. 19 volts. After the MOSFETs, we have 19 volts. What I'm missing then? But the meter is new? No, it's not new. What we're trying to fix today, we have a Dell board. I don't understand why the main panel here, yeah, is missing. The main panel is missing. Okay, let's check the configuration, yeah? So the PD controller, it's outputting 19. So here we have 19, 19.7. Do you think we have a power supply which is creating the main power rail? Hmm? You see, like here is supposed to be the main power rail, and it's 0 volts, nothing. We have an interseal chip, and most likely this one is creating the main power rail. But who is switching on and off the main power rail? Here you have 0 volts. Do you think this one? Here we have 0 volts. No, here is something else. Here we have 0 volts. Okay, that's interesting. Here we have a coil with two MOSFETs, two dual MOSFETs. What do you think about that? So this one is buck and boost. Here we have 0 volts. Okay, that means the voltage is coming in here. Here we have 0. Here we have 19. Check on the screen, 19 volts. This little prick is the driver of these MOSFETs. Yeah. This one is not working. The chip it is getting voltage. Here we have 5 volts. Okay. 5 volts doesn't really make me happy. You think the chip is exploded? I mean, can be. Looking weird. No, you cannot use the thermal camera if nothing is taking current. Interseal gone? What about if you have a MOSFET gone? And interseal just, you know, it will use the protection. But why 5 volts? Here we have nothing. Now one second, no, here. Yeah, 5 volts. Here, 5.7. Wait, from where this chip is getting power? Because I'm pretty sure it's not working with 5. 0. Try to replace and check. No, we have to be sure before we are replacing. Where is the plus of this chip? Who knows? 5. Why 5 volts? Check the input size. Nah, this never get burned. No. You will see it burn if it's burned. Okay, let's unplug the charger and let's check the MOSFETs. I mean, you know what? Let's take a break because I can't work with this. Someone asked yesterday, sorry, why you always use the red probe at the ground? And that's the reason why. Now I have to fix my. Can I? Oh yeah, I can. Huh? 1 second. Yeah, it's fixed. Perfect. Wait, this one is not okay. It's different. It's a different probe. Anyway, it's working. Yeah, all good. What probe is that? Probes. Let's try to find a data sheet. Interseal 9538. 9538. 9538. Data sheet. Bidirectional buck boost voltage regulator. And this is the schematic. So we have this ADP. ADP has the internal and VDD the same. VDD. What VDD is doing? I can't see any VDD. Oh, here. DC in. Okay. But this is an adapter side. That's and yeah, we have to check this one and this one. No, actually this one. DC in. DC in, which is pin number. What is the chip? Pin number DC in. Pin number 17. Pin number 17. Pin number 17 is here. That small pin. Voltage. Yeah, we have 20 volts. Okay, and VDP, where is it? DC VDD, right? One second. No, ADP. Yeah, one second. I can't find the chip. ADP. ADP pin number 16. Which is this one. And we have 19. Oh, lol. Okay. Let's check the MOSFETs for short. Maybe I can't see the chat because I have the data sheet. PC screen. The chat is not even on screen. Microscope. Let's check the MOSFETs. Good. So we have dual MOSFETs. From here to here is good. I want to check with plus and minus, and they are good. Gate is good. Gate is good. So that one is good. No, with the coil, yeah. So here you have a MOSFET gate, and this one with gate is short. Why? One second. So here we have the middle of the MOSFETs, right? Middle. Middle with gate should not be shorted. Middle with gate. Now, on any case, the middle with gate should not be shorted. The middle is where is the coil, is between the MOSFETs. With gate, no. So what do you think? Because it can be normal. Shorted chip or MOSFET? Take out the MOSFET. The chip short gate if it's disabled. Yeah, it is possible to be normal. Shorted MOSFET. Nah, let's take out the chip. Let's take out the chip. In any case, we're gonna replace the chip. Nozzle. Perfect. This is still 0 ohms. Why that is 0 ohms? Because it's normal. Okay, let's find another chip. We said 9538. Should be here somewhere. Interseal. No, it's not that one. No. 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 Can we find like a brand new chip here? Interseal. No, it's not that one. Interseal. 9538. Check here. A brand new chip. Huh? You see? Brand new chip. Yeah, let me take the dust out. 9538. Are you sure it's 9? Yeah, 9538. Yeah. Okay, pin number 1, which has to be there. Perfect. On the other side, the chip looks like brand new. Brand new Indiana Jones chip. Okay, let me dip the chip into the rosin. Good. Let's solder the chip. Perfect. Yeah. Well, the chip it is soldered on place. Brand new chip. Brand new tested. Yeah. Yeah. Draco, good morning. Magic tin? Yeah, it is magic. Good. Let's plug the charger. Plug in the charger. 19 volts, same like before. Nothing. Dead. Dead. Pressing the power button, nothing happened. That means it's not working. Because the output is 0 volts. Yeah. Okay. Probably my chip is dead. $9,538. Okay, we have to find another chip. Interseal, no, it's not that one. 9241, no, it's not this one. But it's good to know I have it. No. Okay, my magic box run out of chips. We have to pick up one from a board. You're using all brand new chips. I've rushed to NASA. Yeah. Let's find another interseal chip. Looks like this brand new chip is faulty from the factory. BQ, no. We have to check every board. Every board. again. Interseal 9538. That's what we need. 9538. Yeah. Found it. It's water damage, but yeah, that's fine. That's okay. Just a little bit of liquid damage. We found it. Oh yeah, it is clean. It is clean. Good. Another brand new chip. Yeah, it is. It is. Pin number 1 is the perfect. Good. So the chip it is soldered. Laptop fixed. No, it's yeah, the main power should be present. Because if the main power is not present, you don't have 3.3. Plug in the charger. And nothing. That's crazy. Main power rail. Now we have to go and check with main power rail 0 volts. Okay. We have to really check the things here with the data sheet. Good. Okay, that's fine. Pin 4 and 5. That's the current sensor, right? So you have one current sensor here. Here is 0 and 0. And you have one current sensor here. And here is 19.8 and 19.8. So the current sensor, it is good. Then we have what for empty socket on board? Empty socket. What do you mean empty socket? Huh? Sorry, I forgot to switch. That's how the board is coming. Some boards they have the GPU, some not. Yeah, so here you have 19.8, here you have 19.8. Yeah. Then according with the data sheet, we have to check ADPS, yeah? ADPS, which is kind of like AC detect, right? Yeah, ADPS, which is pin number 13. Pin number 4 from here. 1, 2, 3, 4. This one. And here we have 18.8. Huh. Okay. Wait, 1 second, 1 second. We have VDDP, which has to be 5 volts. But it was 5. We checked together, right? Yeah, it was 5 on the beginning. You remember? We checked here. And here is 5 volts. Check there. Yeah. So the internal regulator is working. And VDD has to be 5 volts also. VDDP and VDD. What is it? VDDP. Okay. VDD and VDDP. VDD is pin number 18. Pin number 18, which is this one, 5 volts. Hmm. Hmm. How is your mood today? I believe both MOSFETs are burned. I mean, why I will have like short between 2 pins on a MOSFET? Power good? What power good? What do you mean power good? Power good. We have no power good here. Power good is output from a power supply anyway. Okay, let me be sure about the MOSFETs because it's strange. I have short between 2 pins and I don't know why. Okay. So what is not making sense it was actually this pin and here. It's shorted is 0 ohms. That's crazy. Why I have 0 ohms here? Huh? So from here to here. Why I have 0 ohms here? Wait, one second, 1 second. E6936. E6936. Data sheet. Okay. We found it. So basically, we have short between D1 D1 and this D2. I mean, why? D1 and this one. Why you have short with D1? 1 second, 1 second. So basically, those are together. This one and this one on the MOSFET. Basically, here or here. Yeah, I think here. One second. So the MOSFET is like that. So my problem here, these pins, they are not together. But this one is shorted with this one. Yeah. I think I'm confused. Here it's telling me the D1 pins are together. No, 1 second. Wait, it's not D1. No, it's this one, D2. Okay, and here we have, that sucks. Okay, here we have like a track inside of the MOSFET. So this is from the top. Yeah, from the top. Okay, no, it's fine. The MOSFETs are good. And we have the G. Okay, that sucks. We solved nothing. The MOSFETs are good. So here is normal to be a track from here to here. Basically, those are gates. Gate, yeah. So if I'm checking the gates, which are this, oh, you can't see, sorry. Checking the gates and are fine. Yeah. MOSFET is not shorted, obviously, so all good. Back to square one. We don't know why this power supply is not working. We have no idea. Good, so the MOSFET is back in place. Fine, fine. Fine, yeah. And this one we gate. Good. Good. Nothing wrong there. You know what? I think we are missing something, and we are missing communication here. So it is possible the AC chip is supposed to be on, even if this power supply is not working. Or not. Yes. Yeah. So the 3.3 is supposed to be, the AC chip is supposed to have power. Yeah. You see? We are misled. We have to think like to see like the big picture. It's same like the BQ chip. So when the BQ chip has power, the AC chip has power. Yeah, definitely. Definitely. Must be. We don't need schematic for that. No. Good. AC chip is dodgy. We're gonna check now. Liviano. Hello. Chip enabled? What do you mean chip enabled? 1 second. Let me switch my phone. Chip enabled. Enable? What do you mean enable? We don't have an enable pin. This divider is enable the chip to work. Okay. So the AC chip is here, and I want to focus a little bit here, just to see what we have. Shorted, no shorted, things like that. We have an MEC chip. Ground. No, looking good. Huh? Okay, where is the LDO power supply? LDO power supply. I mean, the LDO can be actually inside of the PD controller. Hmm. You know what? I don't know where to go on this case. I mean, we check the chip, everything is fine. Does need to have a battery for that chip to work? Probably not. But it's just probably. Give me 1 second. Is someone at the door? War Diana is here. Okay, Diana is here. What we're doing? Near the TVS diode? What is near to the TVS diode? TVS diode. Wait 1 second. Sylvia, so what you are saying, this thingy, which is a linear regulator, is the 3.3? That's what you are saying? Let's check. Huh? Wait, 1 second, 1 second. Okay, plug in the charger, let's check. Is the TVS diode not shorted? No, it's not. Because we do have voltage at the input of that regulator. 3.3, that's crazy. We do have 3.3, 19 and 3.3. Thank you, Sylvia. So the 3.3 it is present. Huh? Means the AC chip should have voltage. Then why the board is not coming on, I'm pressing the power button if the 3.3 is present. Here we have 0. Here we have 0. Here we have the power button, right? 0. Voltage on the power button, 0. Okay. This is more complicated than I expected. But if I remember, this MEC chip should have 1.8 also. 0. So for some reason the 3.3 is not coming here. None, nothing. We need a schematic. We really need a schematic on this. If we have a schematic, we can fix it quickly. Because I can't see the connection between the LDO and the EC chip. The board number LA G902P. What the hell is that? I have no idea. Cannot be the main 3.3 LDO if the voltage dropped. It's over 16. Alex, not sure I understand. Pablo, buenos dias. Bypass the. I did. I came with the power supply. It's not shorted. A small linear. How can get hot, Alex? There is the EC chip is taking like 50 milliamps. The LDO is meant to provide max 150 milliamps. So the AC chip is always taking less than 150 milliamps. So that chip, it will never get hot, that LDO power supply or that linear regulator. This is not the big 3.3, it's the LDO. Shared on Discord. JFix, thank you very much. Thank you. Wait, I have a moderator which the chat is not working for him. Huh. Um, Radoslav, I will check after stream. I'll try to make you like a power user or something like that. Schematic. JFix, thank you very much. No board view, right? No board view. 50, 100 million should be around. Yeah, that's fine. That's not hard. That's not hard. Good. Ho ho ho. Check here what we have here. So no matter what, we have wait, surely this is the schematic? Okay, ISL 9538. What is the EC chip? Okay, our problem is here. Clearly is here. But I'm curious to see EC chip, how is taking power of the EC chip. This one, which is taking power from the main power rail. What is the EC chip? PCH, EC chip. What is EC? This is the EC chip. So the EC chip, it is enabled. I can't see anything. It's not the same board. I mean, if you can see here, we have the chip. We have the 9538 chip here. So can be the same board. Where are the power supplies? You know, let me check. PU2. PU2. No. Next one. Next one. Where is the here PU2? I can't see it. Is this one? Yeah. No, that's PQ2. Oh, I can't see it then. But whatever is here, I'm assuming is this one, but not sure. Oh, no. This is something else. Okay. PU2. PU2. Check here. This is the one. So this one, it give us 3.3 VDD DC in. Good. Which is used where? Which is used here. Yeah, but this is the input circuit. I don't understand what we are doing here. But this is the input circuit and it's working. This one is a gate. Input circuit, which is working. DC in AC detector, which is working. This one is working. What is here? Here you have a diode. You have operational amplifier. No, not this one. No. We don't care about charging. Oh, we are back on score one. Okay, we are back here. Okay, that's not helpful. No, it's not, Alex. No, you're right. This is not the power rail I'm looking for. Yeah, you're right. Must be another rail. Yeah, you're right. So this 3.3 regulator is not used for the EC chip. Yeah. Novoton. We don't have a Novoton chip. TPM. Okay, TPM. Okay. KBC MEC 5105. 3.3 A. 1 second. Yeah, I can't believe. So the guy with the jobs sent me a nice package from Costa with a little breakfast, and I will say thank you, Aline. Thank you very much. Thank you. Ah, can't believe. Can't believe. Yeah, he's such a nice guy. Hmm? So we have a coffee, we have a croissant. Ah, you know what? I have my breakfast. I will give to Diana. I will give. No cookies today. No, no, no. I have my breakfast. Give me 1 second. I'll give to Diana. Um, thank you. Thank you. Sorry, DM on Discord. 1 second. DM on Discord. DM on Discord. Which one? You are Sandro? Wait a second. This is the same motherboard? You crazy? And the people think I'm dodgy. What is this? So this is the same board, yeah? So check here. This is the same board. So basically you take the chip out and you solder a bridge from the input to the output. Yeah, I tried that. You remember I come with the power supply on the main power rail and it was taking no current. So even if I do that, the board it will not work. I don't know. The AC chip is not it's not taking any power. But yes, I agree. This modification it will work, but it will not charge. Am I right or not? Yeah, it will not charge. So it will work. You have a board which is coming on, but it will not charge. I mean, yeah, we can do something like that, but yeah. The people will say, "No, sorry, you're the most dodgy one." No, no, no. There are people. They are way dodgier than me. uh, yeah, it's not sure. I can do it, but I done it. I came with the power supply. You remember on the beginning. So we have here and we have the main power rail. We try here. So check that. We have 19, but the board is still dead. I mean, it's taking no current. I should see the LDO power supply taking current from there, like 10 milliamps. I can't see anything. Let me plug the charger. So we have the charger. Okay, we have the charger. Where is the power button? Here is the power button. Yeah, good. So we have 19 here. Good, and we are coming with here. Pressing the power button. Oh, it's working. That's crazy. 500 milliamps, and the board is on. I know, but the customer is watching this live stream. I can't do these kind of dodgy things. I know. Okay, you know what? I will do it after the live stream. No, serious. No, 1 second. Okay, so everything is good with this board apart from this power supply, and I'm not happy with that. We have to fix it. It's worth working on it. Okay, yeah, yeah. George, what did you miss? Nothing. No, it's okay. Don't worry. It's bad to learn something like that. Dodgy things. Okay, so the board is fine. So our only problem. What's the problem? No idea. So our only problem is this chip. So I will say, let's take this in serious. We won't tell anyone. Good, great, fantastic. But you see, dodgy people are on the chat. Yeah, I did try on the beginning. Obviously, I tried to see if the main power really shorted, but not on the same time with the charger plugged in and actually trying to press the power button. No, but I mean, it doesn't really even matter because we have to fix it properly. That's the thing. Dodgy people. But it's something to have in mind. Maybe someone has this laptop, he doesn't care about the charging. Then something like that can be done. Okay, let's take this in serious because clearly the problem is here. It's not anywhere else. It's not dodgy if it's functional. Give back the croissant. It's gone. Probably Diana ate it. Am I dodgy enough? Yeah. Okay. So we are. Now let's go back to this data sheet. Yeah. There's no point wasting time with schematics because. Wait, actually, it is point wasting time with schematic, but we need exactly that cheap schematic, which is where myself. Where is it? Where is that ISL chip? Uh, 9538. Yeah, here. This one. Nine five three eight. One second. What is this? This is not our schematic. This is. Oh, the dual MOSFETs are here. Okay, it is our schematic. Yeah, it is. Yeah, it is our schematic. So we check DC and is present. We check VDD and it is present. Yeah. AC in we checked and is present. Um, okay, something is not right here. 13.5 V charging. 13.5 VB. I mean, this is the main power rail. I mean, this should be the main power rail. .5 VB. Let's check another power supply like this one. 13.5 VB. Yeah. So that's the main power rail. Yeah. Okay. I was thinking, it's used only for charging, but it's not. Good. So we have the MOSFET, we have the chip. Not sure what should I check more. That's the thing. We replace two chips and still not working. Maybe I should go to the data sheet. I didn't check this current sensor. Let's check that current sensor. I think focus on the EC chip is pointless to focus on the EC chip. The EC chip is good. The EC chip is good. It's working. The board is starting. No, the board start. You missed that. You missed that point when the board start. No. Hello from Germany. Good morning. Clock. No. No. The problem is here. The problem is it's with this chip. So let's focus here. 95338. Yeah, it's same thing. Yeah, same chip. So we have one current sensor here, but I want to check out the pins of the chip. And it is good. And here 2.5 ohms is good. Then you have a bunch of capacitors, which I'm assuming they are all good. Good. Okay, that's normal. Good. Good. So all are fine. We checked this one, it was 5 volts if I remember. Have a resistor here, resistor here, resistor here. Good. Then we have the gates. We have one gate, which is somewhere. Maybe it's using a resistor on the serial mode. Huh? The gate. No, the gate are not using resistors. No. So the gate should come straight to the chip. Yeah, it's coming. So we have one gate here. We have one gate here. We have another gate here. And probably another one here. No, I can't touch properly there. But no, we are fine. The gates are okay. Here you have a diode, and it's okay. What pin is this one? Oh, actually, this is a gate pin. 1 second. No. V out. V out. V out is actually a divider from the output. No, V out is this one. V out. But why we have, well, a resistor on the serial mode? V out should be from here, and it's not. It's coming here somewhere. You know what? This is, you see, this is not easy repair. Plug in the charger. Definitely, this is not easy repair. So one more time, here we have 0 volts. Okay, so this is V out actually, and here is the input voltage, and it's 19.8. One more time, here we have the chip voltage, which is 19.8. Here we have the 5 volts. 5 volts is present. Here we have the 5 volts. 5 volts is present. Here on these pins we have the input, 19.8. 19.8 is the current sensor. I swear everything is looking fine. What can I check more? Yeah, so this thing is not working. The coil is not bouncing. My MOSFETs are not bouncing the coil from some reason. This is ground, 4.8. What is here? 1, 2, 3, 4. Wait 1 second. It's not a 1 second. But we didn't check this one. Boot 1. Oh, okay, it's a capacitor and a resistor, which probably they will charge the MOSFETs. We have this one and we have one more somewhere with a capacitor on the serial mode. Okay, I'm out of any idea what we are doing. We are replacing the chip or what? Have you seen the schematic, the EC? Needs 3. What? Fafu. The ISL chip needs 3. Really? 1 second. Why it will need 3.3? Where? Where did you see that? This on the OTG pin? This is the output. So monitoring output. This chip has its internal LDO and it's 5 volts. Pin number 19. Wait, pin number 19. We didn't check that. No, 18, pin number 19, AC in charging. We didn't check that. 19. Forward mode enable. Wait a second. Forward mode does mean, and reverse mode when it's outputting voltage to the USB-C, right? And forward when it's taking power from the USB-C. But this is analog signal input. In number 19. And we have 0 volts. Wait, what is this? No, we have 0 volts there. No, it's not connected to ground. Page 37. AC in charging. 37 is nothing on the page 37. Okay, now I'm confused. AC in charging, 1 second, is here. AC in charging. Wait, AC in is a divider. So why we have no voltage on this pin? Huh? AC in charging. Wait 1 second. Number 19. The voltage is greater than 0.8. You know, just strap that. Let's strap that pin to 5 volts and that's all. What do you think? So what this is trying to tell me, it's actually if I short that pin to 5 volts, this power supply will start working. Where is it? Okay, let's plug the charger. Charger is plugged in. No, we don't have board V. No. So we are checking the output. Good. And I bent my thingy. Okay. What the schematic is saying, sorry, if you short that pin to the 5 volts, which we said is this one, it will work. It's not working. No, it's 0 volts. No, nothing. It's not working. So here we have 5 volts. If we are shorting this, all is going to 0. Wait, what? Why my voltage is going to 0 on that pin? Anyone knows? Wait, 1 second. Let me come with the power supply. Power supply, lowering the voltage. Yeah. Coming with current exactly here. And it's taking nothing. Nothing. Higher the voltage. And nothing. It's taking no current. No, nothing. No. Okay, this is strange. Okay, what is your opinion? What is the chat? Your opinion? Yeah, are the same. Are the same. Are the same. Are the same chips. Yeah, I have the genuine chip here. One second. So the original chip is this one. Yeah, this one. This was the original one, which is 99538. You can see. My one is H. This is BH. So yeah, why not check the power sequence? How that can help me? How checking the power sequence? How that can help me? Now you are wasting your time. This is how the repair is going. You don't do random things. Checking the power sequence, it will help you with exactly nothing. We have no problem with the power sequence. Our problem is this chip which is not starting. Put the original chip back, but how this it will help us? We change nothing. I mean, it's not like we change something and now let's put back the original chip. You do now random stuff, and I don't do random stuff. I'm trying to start this chip. You have to focus on the problem. This chip is not starting. That's our problem. You know what? I'm gonna try to find another chip. There is no point checking something else when this chip actually is not starting. I don't do random stuff. Wrong data sheet. It's the same. It's the same chip, same thing. Okay, let me find another chip. How the power sequence can help me? When my problem is this chip. Uh, no. I'm just saying we have to focus on the problem. And that's our problem. The dog, thank you very much for the member. Thank you. Thank you. I mean, this is a basic chip. I mean, it's not like this should work, and it's not working. But we are going back to the same thing. Like we don't have a component which we know it's working. Actually, we know. Okay, if I solder this chip, 100% it will work. I'm sorry, but I'm not millionaire to keep every component on stock. I'm getting the parts from the board. So yeah. Check this code schematic. Just give me 1 second. Let me find that chip. $9538. Yeah, that's the one. And I know 100% this board, it was working. I took the CPU out from this board. 9538. Yeah. I know 100% this chip is good. Okay, happy? I think you guys are getting more frustrated than me. I mean, I'm okay. This is the repair process. This is how it is. Sometimes it's fast, sometimes it's slow. Okay, the chip is soldered in place. Let's plug the charger. And nothing changed. No, no, the main panel is still not present. On this point, I don't believe it's the chip. No. Output voltage 0.4. Going down. No. I'm sorry, but I'm not that good, so I can't figure it out what is wrong with this chip and board. So I know 100% this chip is good. 100%. AC in. What is AC in? Well, we checked already. We checked that already. In number 19. Forward and reverse. Logic high is 3.3. If you ask me, I think it's something wrong here because I have nothing on the pin number 19, which is AC in. But yeah, let's see what the people are saying. Okay, let's see your opinion. Different data sheet. That doesn't matter. That's making no sense. It's okay. It's same. It's same chip. It's same chip. It's not the same. Okay. Discord. Bruno, thank you very much. So you share 95. You share the same thing. Yeah, that's what I have. No way. No way to be different. Wait 1 second. You sure about that? So this is 95338 and this is 9538. No way. You sure? Bruno. Who sent me the schematic? Let's ban the person who sent me the schematic. Yeah, but let's ban him. Who is it? I forgot. I forgot who sent me the schematic. JFix, right? He sent me the schematic. Okay, so our problem is AC in, definitely. So all chips are good, right? All the ISLs. Yeah, let's. I'll put them on the box. Yeah, because yeah. Now we have a bunch of chips here. Good. No, 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 no. I'm laughing now. No, no. It's about I can see people on the chat. They get more frustrated than me, which is crazy. You can't get frustrated. You can't get that angry. Like you didn't fix it. Okay. Oh. Change the chip. But we use the right chip. It's not the schematic, it's the data sheet. Yeah, I know, but this data sheet is telling me a different story. So no, of course it's not coming from the. What do you mean from the? It's coming from here. From you can see AC in 9538. Where is the AC in? Okay, that's a good question. Where is the AC in then? Must be that pin number 19. I'm assuming they're the same. I mean, are kind of the same. You know what? I remember, that's what I remember. I remember I replaced this chip with this chip and it was no issue. That's what I remember. So AC in is from a divider. You can see it here. Yeah, pin number 19. No, on our board, this divider is not working. And this is connected here. You can see it. Yeah. So this divider, which I don't know where it is because we don't have the board view, this divider is not working. We figured it out before. So let's try to have a look. Pin number 19. Microscope. Actually, desk. So we have to find that divider and see why it's not working. Probably it's on this side of the board. Let me see. So here we have a foil. I'm going to take the foil out. So the chip is there, and here on the back of the board, here somewhere, is the divider. Is here somewhere. Probably there. Let me check with the multimeter. Here we have 0. Here we have 1.5 volts. No, we have 0 volts. Here we have 19. Check here. So here we have 19. Here we have 0 volts. Why? And here we have the resistor connected to ground. Why we have 0 volts here? Because I'm pretty sure this is our divider. So either this resistor is burned, which I don't believe this is burned, or this capacitor is dodgy. So what do you think? Let me see the chat. Let me see the chat. 1 second. Where is the chat? Huh? That's the problem? I found the problem before I figured out the chip. I mean, kind of the same. Like I said, I remember I replaced the chip, one with the other, and was working fine. Let's remove the capacitor. Say hello to my little friend. I mean, maybe the capacitor is good. Okay, the capacitor is out. Let's leave the capacitor there. Yeah. Let me cool down the board. Okay, let's plug the charger. Checking the voltage here, and is 0 volts. Ah, lol. I mean, how can be 0? This resistor is dodgy? I mean, the chip cannot be shorted. We replaced the chip so many times. It's a dodgy resistor. I can't believe. How? I mean, where is last time you found out like a interrupted resistor? This never happened. This usually never happened. This kind of fault. I mean, the only device I found like interrupted resistors, part of the dividers, are the TV's power supply. You know, you have resistor on a serial mode to drop the voltage from 220 to down to like 12 volts. So this resistor, no freaking way. So actually the resistor is good. What is this? So from here to ground we have, wait 1 second. So we have 100 kilo ohms. Wait, 400 kilo ohms, but we have no voltage. How this is possible? How this is possible? No, the track is not shorted. I check with ground now. You see, it's not shorted. Now, this is crazy. I mean, of course, the resistor has voltage. But if I short the resistor with this, 0 volts. Getting dropped to 0 instantly. I mean, yeah, the resistor can be dodgy. I mean, checking with a multimeter can be good, but actually it's not good. Let me come with the power supply. So I'm not sure what voltage should be there. Wait a second. Doing. So here is taking no current. So I don't think it's a short. No. 2.5? Yeah, I have 3.8 on power supply, nothing. What is under the second resistor? Under. It's looking good, the second resistor. Okay, let's replace that resistor. Let's find another resistor. Basically a few hundred kilo ohms. Okay. Not sure we can find a resistor like that. Oh, wait, we can find that resistor on the other board from where we got the chip, right? Yeah. So we got the chip from here. And the pin number 1 and the resistor was here. Check here. So we have this pin, it was right? Resistor or not? 1 second. Was pin number 1 like that? No, check here. Here is a divider. Here. You can see it. 2 resistor, capacitor. Okay, so I'm gonna get 1 second. This is ground. Okay, this one. I will take this resistor out and I will move that resistor. Good. And moving the resistor there. Good. Okay, it is solder. Plug in the charger and the voltage there. Wait a second. 0 volts. That's crazy. Why is beeping? 1 second. Why is beeping? I have like 3.6 ohms. How this is even possible? 3.6 ohms. You know what? Let's go with the power supply. Lol, it's taking 300 milliamps. You think the chip is taking this current? I mean, cannot be the chip. I'm 100% that chip was working. But 1 second, if I unplug the charger, just to understand, if I unplug the charger, then it's no short here. No, nothing. So it must be the chip then. No, no short, you can see, no short. But if I plug the charger, wait 1 second, I'm touching different things. Okay, that chip was good. Not anymore. What? This one? This one is not part from here. This one is not part. So we have 3.8 volts and nothing. It's taking no current, nothing. And now it's not short anymore. And we have 0.7 volts. I think we just killed the chip. That's what I think. Yeah, that's what I think. Still don't understand what's going on here. Why this divider is not working if we solder a good chip? Making no sense to me. But I'm gonna remove the chip and check that divider again. Probably the chip has the ability to drag down that power line from divider. Can be possible. So let's see. We have the divider, which is here. Okay, I'm gonna plug the charger. Plug in the charger. The charger is plugged. And we have 0 volts. How this is possible? I took out the chip. Here we have 19 volts. Here we have 0 volts. I took out the chip. Just why? Basically this pin, we have no voltage. We have a simple divider. So what can be wrong here? It's a basic divider. You have 2 resistors. 2 resistors, 1 capacitor. We have no voltage on the output. I don't understand. I swear I don't understand. How a simple divider cannot work? Hmm? Okay. You know what? Maybe it's just yeah, but the bottom resistor are not getting shorted. Voltage should be going somewhere. Possible. You know what? That's actually possible. Because here he's saying he's going to page 37, but on page 37 is nothing. Yeah. Original Dell charger? What do you mean, original Dell charger? There is no original Dell charger. There is USB-C, PD 3.0 or 3.1. It's a universal thingy. No, I believe that truck is going also somewhere else. Yeah, you're right. 2 hours spent on this one. I mean, I can short like, you know, to make the board working, but it's making no sense. They should, you know, just customer want a working board charging, not just working. So basically, we don't have the schematic. That's not the same schematic. And no board view also. From where board view, Sao? Board view is on Discord. We spent 2 hours on this job. No. We're fine. No. Okay, let's go to something else. You have to accept the loss. We can't do it. It's not worth it. Anyway, it's not worth. It's not worth doing it. I'm sorry. Let's plug a USB-C. Let's see what it's doing. We have two same boards. Cursing? Nah, I'm okay. You have to accept the loss. I mean, this is a live stream. That's the reason why I'm trying to fix that board in 2 hours. But usually I don't do something like that. I can fix it quickly. I can figure it out. Okay, otherwise it's no worth. But we are just keep going because it's a live stream. Plugging a charger is doing nothing. Probably this one is not even charging on the USB-C. So we have two different boards. Yeah, it's not charging on the USB-C. But how the power is getting into the laptop? Here? Give me 1 second. We have the whole laptop. So if I remember, we could not fix this one. If I remember, but let's we already checked this one. Let's plug a charger and see. If I remember. 19 volts. Let's see what this laptop was doing before. Plug in the charger. Wait, the battery is down. Pressing the power button and it was coming on, taking no current, if you remember. Yeah. Yeah, good. Good. And we said the ECG must be faulty, but we have two different boards now. We have two different boards. Good. What was the other? I don't know. I have no idea. But the people start getting pissed off on the stream, and I stopped working on that one. I mean, I understand. We work like for 2 hours on that job. So the board is taking like 30 milliamps, 40. Pressing the power button. And the board kind of like coming on. Let's plug a RAM memory. We RAM memory. $130 milliamps, 120, 60. Okay, it's taking like just a little current. Let's see if it's charging. Let's see if it's charging. 1.7 amps. It is charging. It is charging. Okay. Good. Eight ohms. That 8 ohms doesn't look good. This one. Here we have 0 ohms. What is this? 0 ohms. 0 ohms is the CPU chipset, right? Must be the chipset. Coming with a power supply. I mean, we are on the live stream. I'm still on the last job. We are right now on the live stream, but on a real life, that's the way you learn. It's not worth the money, but you just spend time till you find the problem. I mean, it's nothing frustrating. I mean, I know it's boring, but that's how you actually learn. That's how I learn. You just keep going. Okay, so we have 1 volt and it's taking 4 amps, 5 amps. And what is getting hot is actually the chipset. Yeah. So we agree here we have a dead CPU or not? Huh? Dead chipset, right? Taking the power. Yeah. This is a dead chipset. Okay. Taking 5 amps. We all agree with this, yeah? But at least we can move the EC chip from this board to the other board. Huh? Remember the other board which was it was not starting the power supply, you remember? Yeah. So we can assume we have a good BIOS chip and good EC chip, and yeah, we can combine something. Good. So we know what's the story with this one. We can use it for spares. Then let's check the other one, this one. Let's check this one. Christopher, thank you very much for your donation. Thank you. Or replace with a good CPU. Yeah, that's what we are missing, huh? A CPU replacement live stream. Definitely, it will be nice. It will be a good live stream. Um, let's plug the charger. 19 volts. Good. And it's taking like 10 milliamps. Pressing the power button. Wait 1 second. Power button. And it's coming on. It's taking like 700 milliamps, 800 milliamps. We have RAM memory. The screen is not plugged in. 1 second. Let me plug the screen. So the laptop is coming on. It's taking like 800 milliamps. The CPU is mad hot. 1 second. So this is a good board. Wait, the heatsink is not the same. The heatsink is not the same. So basically, it's different CPU. Ortega, thank you very much for your donation. Thank you. Thank you. Lucas, how is my day? Good. Good. You know, we're trying to fix something. Sometimes we can, sometimes not. It's okay. Let's cool down the CPU. So if this board is working, it's nothing what we can do here. Pressing the power button, yeah, it's coming on. Trying to cool down the CPU. You know what? We have no picture. Keyboard to see the error code. Nothing. No error code. We can assume this is a faulty BIOS. Can we assume that? Behaving like a short? No. I mean, can be RAM memory, can be. Let's check the RAM slot. Let's see the RAM slot. If it's not the RAM, it's a BIOS. Must be. Or of course, it can be that CPU also, yeah. So on the slot. What is that? What is that? What is that? What is this? I mean, like always, the first 2 pins from the RAM memory. Always is here. Always. This is well no fault on this HP model. Now this is a easy pizza. Alright? Common issue with this board, yeah. This is a easy pizza. I mean, we deserve this easy pizza. Perfect. Let's check now. RAM memory. Charger. Pressing the power button. Good. Lucas, thank you very much. Thank you very much for your donation. Rudy, thank you very much for the member. Thank you. Easy pizza! I can't believe finally this is the first easy pizza from this job lot. Huh? What do you think? It is a easy pizza or not? Just say it. Just say it. Just say it. Let me feel good. How did you have a button join the channel? If you don't have the button, means you are in a country which YouTube doesn't allow the subscription membership. Easy pizza? Hmm? Yeah, definitely. Good. Now let's be greedy. Can be greedy? What do you think? Can we be greedy like once? Do something for money actually? Rudy, thank you very much for the gifted number. Thank you. Let's be greedy and thinking, about the pizza. Yeah, I want one more pizza from this laptop. So we have two boards, one without the CPU and one which is not really coming on properly. So this is let me put a sticker on this one because this is a easy pizza. Okay, I need stickers with pizza. Good, so this is done. Yeah, so we have two boards and I said this one is that CPU. Let's be sure. Yeah, we have a 0 ohms chip, that chipset, sorry. And we have this one, which I said, you remember I said it's a dead EC chip, not dead. Kind of dead EC chip. So I want to use parts from here and fix this board. Can we? Swap the CPU? No, not the CPU. You can see the CPU has that black red thingy. You can't even swap it. No. CPU rebuild. I don't even have stencils. I have nothing. No. Okay, I will say first. Let's try. Amar, thank you very much for the member. Thank you. EC. I will say let's swap first the BIOS chip. What do you think? We can swap first. But remember, we wrote the BIOS on this one. Rudy, thank you very much for the gifted member. Thank you. Lucas got a gift member from Rudy. Thank you. You can do it. No, I can't. No. You've seen too many, too many, you know. No, no, I can't do it. Board model is different. It's not. It's the same. What do you mean it's different? Oh, lol, it is different. Yeah. Huh? So this one has only one MOSFET. This has two MOSFETs. But basically it's the same. It's different CPU, I believe. Kind of the same. Kind of the same duck. Okay, let's do it. CPU must be different, yeah. Let me solve the BIOS first. So this is the shorted board. Okay. No, I can't see anything. Good, so the BIOS GPT is soldered. We checked this RAM slot. Yeah, okay, the RAM slot is good. Not sure if this board was charging before. I don't remember. Anyway, we swapped the BIOS. Good, so we have. Good, pressing the power button. Now it's taking current. It was not taking current before, you remember? Pressing the power button and nothing happened. Wait a second. With the original BIOS, it was coming on this board. With no current, was taking no current. So before it was taking no current, and now it's taking like 30 milliamps, doing nothing. Yeah, but the lead sensor is here. So if I keep the board like that, try to write the bias, we did it. We already tried that. Rudy, thank you very much for the gifted member. Thank you. Really nice from you. Now it's taking no current. Okay. Pressing the power button, and it's taking 30 milliamps. Let me plug the battery. Plug in the battery. And it's not charging. Thank you, Rudy. Thank you. It's not charging. And even yesterday it was not charging. Pressing the power button, nothing happened. Nothing. Now, you know what? Let's replace the EC chip. Let's try it. We have nothing to lose anyway. Yeah, let's do it. Let's do it. Let's replace the EC chip. I know it was taking, but after I plugged the battery, it was not taking. Okay, let's double check. Let's be sure we are doing the right thing. So with the charger plugged in, it's taking no current at all with the charger plugged in. And we are pressing the power button, it was taking like 30 milliamps. Where is the power button? Here. But the thing is not charging. It was not charging even with the other BIOS chip. Wait a second, I'm plugging the board and it's taking 30 milliamps? That's not right. Why? Huh? But this board is good. Wait 1 second. No. I know it told me. No. You're wrong. I mean, it can be a different board, and yeah, that's why it's not the same. But we test a good board. We have a good board there. We fix it. You remember? The one with the RAM slot, and it was working with this board, not the same board. Yeah, that's what I'm thinking. It's not the same board. The good board also was taking? No. What do you mean? No, the board is taking no current, but when I'm plugging this thingy, it's taking like 30 milliamps. Check there. You can see. So not sure what is, but we can find out what is taking 30 milliamps. I don't know how that can be helpful. Now it's taking 0. Wait 1 second. It's the lead sensor. Yeah. So when I'm putting this thingy back, check that is 0. 0. The lead sensor is shorting the 3.3. You can see? So if I take the board out, you understand, if I come with a magnet, just to understand, I have a magnet here. Yeah, magnet. He's taking no current. You can see? So yeah, the lead sensor is shorting the 3.3. I don't feel it. That means this board is not the same with the other one. So what we are doing? What do you mean swap the EC chip? You don't understand. We don't have a power button on this board. Let's find the power button. The connector is different. Wait, what do you mean the good board was taking 30 milliamps? Okay, let me check the good board. So what you're trying to tell me, actually this board worked with this, huh? Well, it is the same board. So if this board worked, this should work, right? Even if it's taking 30 milliamps. Okay. At least we know what is the problem with the lead sensor. Good. It's okay. Let's swap the EC chip. EC chip replacement. (480°) microscope. Good. Wait. I need a special tweezer. 1 second. Yeah, I found it. Yeah. EC chip position. And the EC chip is out. So that's the old one. 128. Good. And the new EC chip from here. Oh, well, this is not even the same. We can't do it. One sec, we have a different EC chip. So this is IT 5570 and this is A9A7. Nah, it will not work. It will not work. No, 100% it will not work. 100%. Brand new tin? No. So this one, the CPU is shorted on this one. And now, okay, now. We tried, but it didn't work. Oh, we have a brand new EC chip here. Okay. So this laptop is fixed with this board. So the customer has a good board. Good, perfect. And battery, yeah, and battery. Let me leave this on one side and let's start something else. Give me a minute. I need to make a phone call. Diana has to go and pick up some jobs from a computer shop, yeah? And I need a cigarette. 1 minute, yeah? 1 minute. Sorry. Um, we are back and we have a nice laptop, right? We have i5 and RX graphics, Acer. Hmm? Let's see what's the problem with this one. We have that funny charging port. Let's plug a charger. This one. 19 volts, plug in the charger and stick in 10 milliamps. Good. Pressing the power button. And it's taking 70 milliamps. Okay, that's bad. So it's kind of starting. $70 milliamps. What is taking 70 milliamps? Another chipset. Yeah, but check for main B plus short. No, it's not short because it's working. It's coming on. The EC chip has LDO. It's reading the power button. Everything is fine. Actually, we should check the coil resistance. Yeah. Let's see the coils. Coil is good. Coil is good. Coil 154. This is good. You know, the coils are good. 17 ohms the CPU. The thing is, what I can see here is some liquid damage. Shorter CPU? No. Let me check the board for the liquid damage. Yeah, we have a RAM memory. Yeah, it's not my one. My one is here. Let's be sure we don't have liquid damage. I check here. You can see liquid damage. We really have to check this board. Liquid damage. But the thing is, the board is looking good. We have a onboard RAM. No, it's not liquid damage on this board. Ah, lol, someone played on the BIOS chip. Yeah, then it's making sense. I mean, it's looking like a BIOS issue. Give me 1 second. Okay, I have some problems. I have the guy which is checking the gas. He's doing like checking every year, and Diana is not home, and I'm the only one. I have to go there. I have to stop this live stream, yeah. But probably see you later or tomorrow. Okay, I'm really sorry. No, no, it's the guy who's checking the gas. You know everything with the gas, the inspection, like annual inspection. Okay. Thank you for being here, and see you probably tomorrow or later. Yeah. Bye.